We're on the ground running for this newest edition. We're going to find out what's happening right now and what people are doing to prepare for the future. It's a lot to pack in. So let's travel on down to Sun Microsystems and get right to it and take a look at their new data center. So I'm here at Sun Microsystems and I'm talking to Dean Nelson. Not only is Dean responsible for the data center and labs here at Sun, but he's also one of the co-founding members of the Data Center Pulse. Tell me why you chose hot aisle containment.
So actually in this project we have the world's largest single installation of APC hot aisle containment. This is the most efficient data center in our global portfolio. It's also the highest density and it's on slab. So I shed $4 million worth of costs inside of the project by not deploying raised floor. This PUE of this data center is 1.28, which means that 78% of the actual power is going into the actual IT load.
You've been telling me that you've been gradually raising the temperature. Where are you at now?
So we're at 74 degrees inlet to all of these different pods. And then inside of the hot aisle itself, we'll go take a look at that in a sec, it's between 95 to 105 degrees. Yeah, no, the whole point is that you're isolating the heat. And when you do that, you can run the data center a lot warmer. And every degree that you increase the temperature in a data center, every Fahrenheit, is a 4% efficiency gain all the way through to the plant. This is the hot aisle.
Oh, I can feel it. It's hot, all right.
So it's between 95 and 105 degrees depending on what kind of equipment is in here. Air conditioners in row with the actual equipment. So the servers are sucking in the actual cold air. They warm up as it comes out here, and then it gets sucked back through both of these units, and it blows out cold air in the front. And so it can actually dynamically go up and down based on whatever it's sensing with the load itself. This is the kind of stuff that enables you to make changes or turn on a dime.
Now we travel to Stanford University to meet with Professor John Kumi, who will share some insights into cutting and controlling your facility's energy costs.
In existing facilities, in existing data centers, there's a lot of provision for improving the efficiency without large capital investment, just changing the operation. So one thing you can do, Ken Brill at Uptime talks about between 10 and 30% of servers in typical data centers are what he calls comatose. They're sitting there not doing anything but using electricity. And so you can get rid of those, right? That's one thing you can do. Another thing you can do is you can look at the airflow in your facility. And in a lot of these facilities, you have hot spots, you have cold spots, but you're not delivering the cool air to the places that need to get it as accurately and as cheaply as you could. And simply by looking again at what's going on in your facility, there's ways you can change the operations that don't cost a lot in capital. Typical data centers can save 10 to 30% pretty easily.
We're seeing that facilities in IT are doing a better job of communicating with each other, but they're still speaking different languages, right? And so is there another new language to learn for these guys to communicate?
Well, I think the language is dollars. And now big companies like Microsoft and others are, for their internal data centers, charging their users per kilowatt. And that turns out to have a big effect on how people make choices when they're putting in new servers.
So you got an IT guy getting a power bill? How's that going over? Is there any pushback in those kind of arrangements?
Well, when you first start talking about this, there's almost always some pushback. But at the end of the day, you want people to be thinking about total costs. And if people are not being charged for the costs that they're imposing on the society, then the data center is going to be a whole lot less efficient.
So if you could say one gem in conclusion for our audience, what would that be?
Start measuring now.
Okay.
There's huge potential, and if you start measuring, you'll find the real sources of opportunity and capture them.
Well, you sold me. I'm going to start measuring right away.
Okay, thanks so much.
Thanks a lot. Bye. Imagine having to build a data center in a high-rise under traditional floor space. Well, Adobe's Dave Morrison had to meet that challenge.
We're standing in a space that used to be an aisleway with conventional offices. Installed two separate air conditioning systems in here. Okay. The first is conventional crack units that feed overhead ducting that's on the other side of the server cabinets here. And the second is XDC systems, and you can see one of the XDC chillers right here. And this feeds refrigerant to these overhead XD units. We also recognized that there was a high probability that we were going to have short cycling occurring. In other words, the cold air from this side mixing with the hot air on the hot aisle before it ever had a chance to go through the server cabinets. And then we had our general contractor bring in a smoke producing machine, and sure enough, the smoke did show an airflow pattern of short cycling. So then we came back, installed all these curtains everywhere, and that seemed to solve 90% of the short cycling problem.
So I'm looking at the doors here, but it's not just the doors, it's above the racks. You've buttoned up everything on top of the racks to make sure the air doesn't flow over the top as well.
So Bob, what we're looking at here is our power distribution sub-panels. CTs installed on each circuit that connect to a data collection module down in this cabinet that is used to actually monitor the power on the IBIS system.
The IBIS system Dave just mentioned is from a local vendor who implemented and customized Adobe's power monitoring system. They even used Adobe's Flash software product for the display. It allows the engineers to drill down to circuit level for monitoring of critical building systems. Besides this large graphical display, the software can be called up from anywhere on the network.
I think that with the foresight that we had from the get-go to put everything together the way we did, that we're going to be able to avoid doing very much work in here at all after the fact. It's all ready to go.
So that was cool. A data center on a converted office floor in a traditional high-rise. What could be next? No data center? Maybe you just blow up your servers? So how many ways can you blow up a server? Well, that was a clip we got from GoGrid.com. That's a cloud computing company, and of course they're trying to make their point. But you think about it, how is cloud computing going to affect your planning for the future? To find a vision of the future, we travel down to VMware Systems and talk to Mark Thiele. He's their Director of R&D Operations. Let's get right to it. What's the data center of the future look like, Mark?
Well, cloud computing and virtualization together really create an opportunity for people to use their data center as a total resource. In a traditional environment, building a Tier 4 or even a Tier 3 data center can oftentimes cost you as much as one data center can cost you as much as building, say, 2 Tier 2 data centers or 3 Tier 1 data centers. So instead of putting all your eggs in one basket and then still having to have a recovery facility somewhere else that is effectively cold storage, the real idea here is to build a Tier 1 or Tier 2 type facility, but build 2 of them.
I can feel the audience out there getting a little nervous. There's a lot of those people that just finally got comfortable with the fact that, you know, they do need to have a redundant system. Now we're talking about resiliency instead of redundancy. How are we going to get comfortable with this, that it's okay to fail?
For the vast majority of organizations, the ability to quickly move your applications in the event of a disaster from one place to another, or effectively having them run in more than one place all the time, means that the facility itself isn't as critical from a capability standpoint as it was this year or last year. You know, what is the reward versus the risk, right? So what is the risk I'm concerned with? The risk I'm concerned with is that I might lose an application for 4 hours, or I might have a failure in part of my data center for a period of time. If that risk is $500,000 for a 4-hour outage, but I'm saving the company $300,000 a quarter in power benefits alone, not to mention all the other features I've enabled, then that's a risk you need to take. Yep.
You know, that got me thinking, resiliency versus redundancy, embracing failure. You know, the other thing I started thinking about, what about security? You know, can you really trust your information up in the cloud? For answers to that, we actually traveled to a cloud environment to speak with John Pierce from IBM. We're going to ask him those questions. John used to work for the CIA and is an expert in security. So John, as our viewers are thinking about going into the cloud environment, regarding security, what are the top 3 questions that you should be asking, and what were the answers that I want to hear?
Absolutely. So one of the questions I'd ask is if they have deep packet inspection technologies, such as an intrusion prevention system or UTM, Unified Threat Management System.
Tell me a little bit more about deep packet inspection.
Okay, so deep packet inspection is really looking at the packet as it's coming through on the wire. So when I talk about intrusion prevention as an example, this device sits in line, and what it's doing, it's looking at every single packet that's coming through the network or before it gets to your network. And what's important to know, it's looking all the way up from layer 2 all the way up to layer 7 to the application layer. So as this data is coming through the wire, it can be compressed and it can be in a compound document like a Microsoft Word document. Well, some DPI technology, specifically ours, has the capability to look into that whole entire packet, decompress it if it was zipped up. We can go in there and we can look and see if there's anything malicious. So knowing that they have deep packet inspection, I think is key. Another thing that I think is really important is data separation.